You will see this physics question on your MCAT.
Question 5. In a nearsighted individual, the image of a distant object is focused where? So a nearsighted individual is one that is called myopic. So nearsightedness is myopia. And that can either happen if the eyeball is too long, so the diameter of the eyeball is too long, or if the lens, okay, of our eye is too strong, such that it focuses the light rays instead of on the retina where they should be focused to get a clear image. And specifically, they should be focused in the region of the retina called the macula densa, where you have the highest concentration of cones or color detecting photoreceptors, okay? Instead of focusing it directly on the retina, so R, they just focus somewhere in front of the retina, right? And again, that could be either because the diameter of the eyeball is too much or too big, or because the lens is too strong. And our lens is a converging lens, such that light rays that are hitting it, okay, if these are light rays, they are converged to a point, like this, okay? And so normally they should be converging on the retina, but in an individual suffering from myopia, they converge in front, okay? And so in a nearsighted individual, if you have a distant object, and distant objects, if you're myopic, you have more trouble seeing distant objects, okay? They are going to be focused in front of the retina, right? And the way that you would correct that is you actually want to put a diverging lens in front of that eyeball, and I'll demonstrate why that is, okay? So again, if we draw the same thing, right, without the diverging lens, it's going to be focusing here, but we want it to be focused on the retina. And the reason we can put a diverging lens in, which would look something like this, in front of our own lens here to fix this problem, is because when the light rays hit the diverging lens, okay, they are actually going to diverge further out away from each other before hitting our own converging lens. So when they hit our converging lens, they will be further apart from each other, such that when our lens then subsequently converges those light rays, they will converge only at a more distant point, which, if we choose the right strength for our diverging lens, will be our retina, okay? And that's why we're going to use a diverging lens to help correct myopia, okay? So A is the right answer. Now, if we were talking about hyperopia, which is basically farsightedness, where we can see better things that are at a far distance and we can't really see something that's close to us, like we can't really read a book very well, then that happens because the eyeball is either too short or our lens is not strong enough, right? So as a result, the light is focused behind the retina somewhere, okay, somewhere down back here instead of here. And we correct that using a converging lens instead, okay? So, but in this case, to fix myopia, it's going to be a diverging lens.